this is your 2C-2 application video. I'm going to try to make it really quick to make up for the really long 2C1 video that I did last time. So Jake is paid $8 per hour mowing lawns in his neighborhood. We're told to let T be the amount of time he mows lawns in hours during the week, and let P of T be his gross pay in dollars for the week. So our input is going to be time, which means I can go ahead and label this graph. My x-axis is going to be the number of hours. My y-axis is going to be the money he makes. But the first thing I'm asked to do is complete the table showing his pay depending on the amount of time he works. So if he works 0 hours, then obviously he's going to get $0. If he works 1 hour, the problem tells us he's getting $8. If he adds an extra hour, then that's going to add an extra $8. And then I'm going to add another $8 and another and another. And I can fill in this whole table by just continuing to add $8 along the way. So I'm saying 72 plus 8, and I get 80. Now, to graph it, my x-axis I can count by ones, it looks like. For my y-axis, I think I'm going to count by fives, but only label every other one. So this will be 5, which makes this 10, 15, 20, 25, 30, this will be 40, 50. It's hard to see these tiny little lines with my old eyes. 75, 80, and that would be 90. Okay, sorry about the, whoops, computer's fallen. Sorry about the bad handwriting. So to show how much money he's making, definitely at hour 0, he's making $0. Then after 1 hour, I'm going here almost up to 8, and after 2, I'm going to be here at 16, and it's going to continue to grow over time. Now, we're only told his hourly rate. We don't know if he gets money if he's there for half an hour or if it only goes to 1 hour in 1 hour increments. So one way of doing this would be to go through and just do the dots and say this is a discrete function, and I only have at 0 he makes $0, at 1 hour he makes $8, and so on. You could also make the argument that, you know, he might get $4 for half an hour or something like that. So you may connect the line, but regardless of which choice you make, you need to be able to defend the choice that you make. So if you choose to leave the dots unconnected, then that's because you think that he's only getting paid on the hour and he's not going to get paid for partial time. If you choose to connect them, then that's for the reason that I said before, which is if you're there for 10 extra minutes, you should be compensated for that. And different jobs work differently, so you would just need to state that. The last bit is to write, and you should continue your dots too, but I want to make your video short. So the last bit is to write a formula using function notation, showing how his gross pay depends on the amount of time he works. So to figure this out, we could look at our table and find our y-intercept by looking at when my x is 0, what is my y? Well, it's 0. So that means my y-intercept is 0. I can also see that on the graph. And then I can also use the table to find the rate of change. Remember, rate of change is your change in y, and that P of T is my y, over the change in x. So your slope is y2 minus y1, or just change in y, over x2 minus x1. So when I look at the change happening here, I have a change of positive 8 for each of my y values, and I have a change of plus 1 for each of my x values. So that means my slope is 8. So when I write an equation for that, I'm going to have P of T is equal to slope of 8, which means I am multiplying 8 by my, not x, t, multiplying 8 by my time. And since my y-intercept is 0, I would have a plus 0 there or nothing. And that's it, guys. Hope this was helpful. We'll see you in class.